We've now talked about discrete probability distributions and binomial distributions, and now we'll talk about normal distributions. And normal distributions are known as normal curves. They're also known as bell-shaped curves. So the idea is that it looks kind of like this. Some of the main features of this is that this center high point is going to be our mean. In addition, this thing never touches the x-axis. It gets very, very close to the x-axis, but never touches it. In addition, the total area underneath this curve is going to be 1. And sigma, our standard deviation, controls the spread of the curve. It controls how spread out it is. As an example, here is another normal distribution. And this one may have something like sigma equal to 15, whereas my red one would be more like sigma equal to 3. So the higher value of your standard deviation, the much more of a point this thing is going to be. A lower standard deviation means it's a lot more spread out. So now that we have a basic understanding of what a normal curve looks like, let's talk about some of the things that we can tell with this. The first thing we're going to look at is the empirical rule. So if I consider a standard normal curve, let's say this one. Like I said, this middle point is mu. And then roughly along these lines is going to be sigma plus mu, 2 sigma plus mu, 3 sigma plus mu. On the other side, we'll have the negative standard deviations, minus sigma plus u, minus 2 sigma plus u, and then minus 3 sigma plus u. So we're looking at how many standard deviations we are away. And what the empirical rule says is that between one standard deviation on either side is going to contain 68% of our data. Since this is symmetrical, it tells me that each one of these portions contains 34% of the data. The empirical rule also tells me that between two standard deviations on either side holds 95% of the data. That means on each side is 47.5%. So each one of these little things is going to be 13.5% because 13 plus 5 plus 34 will be the 47. Finally, 3 standard deviations away is going to be 99.7%. And looking at that on either side of the center tells me that in each one of these regions, we're going to have approximately 2.35% of the data. And then there's 0.3% of the data out to the very ends, so 0.15 here and 0.15 down here. Now let's look at some applications of this empirical rule. When we're talking about IQ, IQ does have a normal distribution, and we know that the mean is 100 and the standard deviation is 15. So we want to know what the probability someone has an IQ between 100 and 130. Well, 100 is our mean, and we also know that our mean plus 2 standard deviations is 130. So our empirical rule said that there was 95% between 2 standard deviations. So we don't want to consider 2 standard deviations above and below. We just want 2 standard deviations above. So 95 over 2 is 47.5%. So the chance that someone has this IQ is going to be 47.5%.